complex concepts of physics in lucid terms, both in classroom setup and in written format, which has made him popular among students as an exceptional teacher and has brought him the fame of being a celebrated popular science writer. He has received 2 awards for his contributions to popular science writings in Bengali. First in 2004, the Ravindra Shriti Puruskar, and second in 2011, Ravindra Sundar Shriti Puruskar. The second one actually he has received for his book, which is named Einstein Ne Uttarajita, and if I say it in English, it should be Einstein's Legacy. And I happen to have read that book, and the very first chapter was about why Einstein was and is still very famous. And when I read that article, I was literally awestruck by the method of his analysis and the logic laid by him to analyze or address such an unusual question. I'm very happy that Professor Pal has chosen this topic for today's talk, and I'm sure you're going to enjoy as much as I enjoy reading his article. Before I invite Professor Pal on stage, a few more words about him, without which I don't think that an address to him would be complete. He is not only an renowned physicist, but he is also an acclaimed linguist, a poet, and above all, he is the creator of the first LaTeX-based Bengali fonts, which is called Bangtex. So with this, I invite Professor Palash Baran Pal on stage to deliver today's lecture on the scientist fame. Palash Baran, the stage is yours.
Thank you, Suratna, for inviting me and for the introduction. I hope I live up to it. For many reasons, this is an unusual talk. This is an unusual talk for me. I don't think I have ever given a talk at 6 o'clock in the evening.
You maybe forgot. Your ID can't our calendars.
Yeah, see? Well, that happens when one is old, one forgets. Yes, you are right. So I gather it was a memorable talk. Okay, there are other reasons also. Like, the subject that I'm going to talk about here is less of science and more of sociology kind of thing. And I have never given a talk on this. I wanted to summarize these statements by saying that this kind of talk is not really my cup of tea, but that would be a very strong statement coming from me because I don't take tea at all. So anyway, let me start. Originally, I thought that I would make it a general discourse on the fame of different scientists, but then I thought that that would take too much time. Probably I will get too much distraction from many things. So I decided to just keep my attention on just one scientist, namely Albert Einstein. I will of course make sometimes some comments about others, but the focus will be on Einstein. And let me start by telling you an anecdote which I heard from another physicist, a senior physicist, Joseph Sucher. Joseph Sucher was a professor when I was a postdoc at the University of Maryland. And we always used to call him Joe, so I will also probably mention him as Joe. And the story also involves his wife, whose name I'm not sure that I remember it correctly, and Joe will forgive me if I say it wrong, but for the purpose of this story at least, I am adopting the name Dorothy. Now once, during the summer vacation, Joe went for about a month to a place near the Atlantic Ocean, and where there was a physics institute set up, And a little away from the physics institute, there were cottages for physicists to stay. And the cottages are not exclusively for physicists. The cottages are meant for anybody who would come here. So many other people also lived there. So Joe was there for some time. And he was there for doing some work at the institute. And his wife also accompanied him. But Joe used to go to the institute during the daytime, so his wife would stay alone at home. Now then she found out that there was another person living in the next cottage, and so Dorothy became friend with this woman in that house. So they started talking about many things, as it happens. Now then once this other woman, the neighbor, asked Dorothy, by the way, let me ask you, where does your husband go every day? Does he have any kind of business here? So Dorothy said that, well, I don't know if it can be called business, but he goes to do some work. So then the woman asked that, what kind of work? Dorothy said that, see, he is a professor of physics in the university and he does some research on that, so he goes to do some research. Now, this was a very difficult sentence for that other woman. She comes from a background of a family which has some farmland in the Midwest of the United States, and she has never heard anybody. She knows what university is, but she has no idea what is physics and what is research. So then she asked Dorothy, what did you mean by this thing, physics, and what is research? Then Dorothy was not sure how to attack the problem. So after a little thought, she said, see, have you ever wondered how the sun shines in the sky, or how the moon, the stars, the planets move around in the sky, how they give light, how there is the web and the tide in the oceans, and why the moon, while going around the earth, doesn't fall on the earth's surface? Have you ever wondered about these things? So this woman was extremely scandalized. She said, come on, those are the things for God to think about. Why should I think about those things? So Dorothy was alarmed. She didn't really want to pretend that her husband is competing with God. So then she sort of changed the tactics. She said, okay, but have you ever wondered, say, when you heat water, why does it become steam? Or let's say, why a magnet pulls a piece of iron? Or why wearing a pair of glasses is good if you have a myopia? Have you ever thought about these things? She said, no, I've never really thought about this. Okay, so that's another blind alley. So then Dorothy said that, okay, have you ever thought about why the light is on when you press the switch in your house, or why your TV can get the picture and these kind of things which is happening in your house every day? She said, no, I have never thought about these things. So Dorothy started thinking again, how to tell this person about physics. What is physics? Finally, she said, have you heard the name of Albert Einstein? And the woman said, well, of course, everybody knows his name. So then Dorothy said, well, my husband is in the same business. Now, I'm not saying that this story is 100% truth. I mean, there can be some embellishment on truth, and that's allowed. and I don't know how much is embellishment and how much is truth. But the essence of the story is nothing but true. Einstein was and is universally known. Any physicist, while introducing himself or herself to another person, can say that he or she does the same thing that Einstein used to do. It's literally true that Einstein's name is known to everyone on the planet, at least to those who have any kind of education. So much so that at the end of the 20th century, when the Time magazine wanted to find someone who would be the person of the century, they put Einstein's name. So how did Einstein attain a position of such great fame? His discoveries did not result in the change of lifestyles of people. It is not even clear that there was any great change in the philosophy of life because of his discoveries. His fame, as we know, is chiefly due to his work on the theory of relativity, which does not affect our daily life in any way. We do not need Einstein's theory to explain any phenomenon that we see around us in our normal daily life. It does not mean that these phenomena are outside the realm of applicability of relativity, or that it will be wrong to apply relativity to explain these phenomena. The point is that if we throw a pebble and apply Einstein's theory to find the path that it would take to reach the ground, it would be something like what we say in Bengali, it's using a cannon to stump a bug. The bug will die, true, for sure, but a lot of effort will be wasted, because one can do the calculations using Newton's laws of motion, which will be much simpler, and the result obtained from that will not differ from the Einsteinian way by 1 part in millions of millions. The difference will be so small that it will not be possible to measure it through any instrument. So, what will we gain by using Einstein's method? Nothing. Rather, it is much better to follow Newton's method, through which one can reach the answer quickly. The story is the same if instead of a pebble thrown by hand, we think about rockets launched into space. It is Newton's law that is used to calculate the motion of the rocket in the sky. Einstein's theory becomes important only if something is moving at a speed close to the speed of light. And the speed of light is 300,000 kilometers per second. For those who are not accustomed to listening to this number, let me repeat again, it's 300,000 kilometers per second. In Indian English, it's 3 lakh kilometers per second. Compared to this speed, even the speed of a rocket is negligibly small, around tens of thousands of kilometers per hour. Therefore, Einstein is irrelevant. Probably, this is the reason why the subject of relativity has been treated like a matter of great pomp or matter of daydreaming, and many jokes have been created to this effect. It has been said on many occasions by many people, including some scientists, that there are only 2 or 3 persons in the world who understand relativity. The famous scientist George Gamow wrote a book around 1940 about a simple person named Mr. Tompkins, who felt very excited when he saw the announcement of a lecture on relativity, because he had heard that only a dozen persons in the world understood the subject clearly, and he might become the 13th if he heard the lecture. So it is not clear that Gamow himself believed in this number 12, but such opinions must have been around, or else he would not have made such a joke. And yet, Einstein became famous and rose to such heights of fame which can be the cause of envy to any movie star or football player of modern times. The fame did not come instantaneously. Not every person of all ages became a connoisseur of Einstein's theory, but there is no question that he became a legend during his lifetime. Famous people all around the world wanted earnestly to meet Einstein even once. And of course, the list included people who did not who did not have any connection with science. Leading politicians and diplomats of his time invited him for discussions. On what? Let's not talk about that. When the country of Israel was formed, after the Second World War, Einstein's name was proposed as the head of the government of that country, and an appeal was made to him to that effect. Einstein rejected the proposal, thankfully. It is difficult to analyze what really tickles public's fascination. That is why it is difficult to find the reasons for Einstein's fame. There is no debate about the fact that Einstein's discoveries opened new horizons in physics research. But there are many other people who had made epoch-making discoveries before and after Einstein, and yet did not achieve a fame anywhere comparable to that of his. Among the physicists who are his predecessors, probably only Newton belongs to the same category. Although it has to be said that the benchmark of fame was not the same in Newton's times, there were no newspapers and therefore no articles about him written for the general public, no paparazzi, and no photographs either, because photography had not been invented at Newton's time. If we search for names outside physics, we can think of a few more names. For example, Charles Darwin, for sure. However, Darwin's work had a very direct and profound relation with the way that human beings think of their own species. So it is not surprising that Darwin's work had an impact on our thoughts and our philosophies. Einstein's work, on the other hand, did not have any such close relationship with our day-to-day life, and that is why his fame is rather surprising. Let us point out an important aspect of Einstein's fame. In 1905, Einstein attracted the attention of the physics community by writing 5 great papers. But the fame across all parts of society and all around the globe came much later. In 1919, Arthur Eddington carried out an observation at the time of a total solar eclipse and found that the path of light bends while going close past the sun. If we throw a pebble horizontally, it follows a path that looks somewhat like a bow and finally reaches the ground. This happens because of the pull of the earth. Similarly, light also bends because of the pull of the sun or any such super heavy object. This possibility was suggested in a research paper by Einstein that was published in 1915, where the amount of the bending was also calculated. Eddington's observations confirmed that Einstein's calculations were right. And the clamor really started after this event. The scientists were also partially responsible for this outburst. During the time from 1914 to 1918, Europe was engaged in the First World War. Britain and Germany were on opposite sides in this war. Eddington was British. Einstein was born in Germany, though he never really emphatically claimed that he is German, because he really grew up not in Germany but in Switzerland. He left Germany at an early age, lived and studied and worked abroad, but then he was back in Germany a few years before 1919 and started working in Berlin. A British scientist was trying to establish through experimental means the predictions made by a German scientist. Moreover, if Einstein's ideas about gravitation would turn out to be correct, that would destabilize the status of the old theory of gravitation that was proposed by another British scientist, Isaac Newton. Now, liberal-minded scientists made no mistake of making a big propaganda out of this whole thing. What could be a better advertisement of the fact that countries fight petty wars with other countries, but the pursuit of knowledge is much above these conflicts? So they made such a noise that even the press became alert and the general public of England became aware through their reports. Gradually, the wave spread to other countries. Some people say that this is the main reason of Einstein's fame. I cannot fully agree with this explanation. It cannot be denied or even debated that fame could not have spread so fast without the help of the newspaper reports and articles. But the articles appear in newspaper. Why would anybody read the article? There are many things that appear in the newspaper. Why would they appeal to the common folk who do not have much connection with basic science in their daily lives? It is conceivable that the peace-loving people saw in this event a little chance, however little, of reparation of the strained relations between Britain and Germany, and were pleased by that. But I cannot believe that right after a bitter war, the percentage of such die-hard peace lovers was high in Britain. It is not an unusual event in any field of science that a theory proposed by a scientist from one country is being tested by a scientist from another country. So Eddington was not doing something unprecedented. And if the triumph of a new theory over Newton's theory was the issue, then there was a similar effort going on at that time or a little later, which was the birth of quantum mechanics. The three laws of motion of Newton, which explained every aspect of motion of every object for a few centuries, were found to be insufficient for understanding the atoms. In 1911 or 12, Niels Bohr first said that some new laws need to be sought for. These laws were finally found by Erwin Schrödinger and Werner Heisenberg around 1925-26. But there was no celebration of these discoveries outside the community of scientists. So why was the Einstein's case so different? Let me also point out that I am not saying that conflict cannot hold the key for a fame. Sometimes it can. Let us take the case of Jagadish Chandra Bose. Jagadish Chandra, I don't know, at least in my part of the country, everybody knows his name. Not only every school child, but even people who have never gone to school, they also know Jagadish Chandra's name. How did this happen? Because Jagadish Chandra took his theory to England and gave lectures in England around 1895. That was the time of birth of nationalism. About 2 years ago, Vivekananda has also gone to Chicago and preached his Hinduism. But he was talking about a subject which belonged to India. Jagadish Chandra was talking about a subject which does not belong to India, did not belong to India. So he was talking to the English people about European science in some sense. So in some sense, sort of treating them with their own things. And he submitted. So this was a matter of great national pride. And it of course came from the rise of nationalism, which is a conflict, as you see. But then Jagadish Chandra became even more famous in 1902, when Marconi was awarded the Nobel Prize for Physics. Now Jagadish Chandra became a tragic hero. He was the person to whom fame was denied. So everybody started to say, oh, this is great injustice being done to Indians, and so on and so forth. So that is how his fame started being spread outside the realm of physics. But in the case of Einstein, I don't think that this kind of things are the right thing, because in the case of the relation between England and India, there was a clear hierarchy at that time. The British ruled the India. So rising against the British would be seen as something heroic. In the case of Germany and England, there was no such hierarchy in relations. So that argument doesn't apply. And Einstein never became a tragic hero. He rose to fame. So coming back to Einstein, I think that there are two main reasons for his fame. The first is the circumstances in which Eddington performed his experiment. It is nearly impossible to determine whether the path of a light from a distant star bends while passing close to the sun if the sun is in the sky, for the simple reason that the light from the star is not discernible in the backdrop of sunlight. So, what I mean to say is that one cannot see a star when the bright sun is shining in the sky. So the observation must be made at a time when the sun is in the sky, but we don't see the rays of the sun from the earth. That means it will have to be done at the time of a total solar eclipse. Such an opportunity is the one that Eddington took, and he made his observation at the time of a total solar eclipse in 1919. Now, a total solar eclipse is a very, very dramatic event. Anyone who has seen it knows. In fact, there are very few events that we can see with our naked eyes which is more fantastic than the descent of complete darkness in the middle of a bright day. So any total solar eclipse attracts a lot of attention from everyone. The news of testing of Einstein's theory came in the same newspaper report where they were talking about the impending solar eclipse. So they were coupled. The thing was coupled with the solar eclipse, and that is why it attracted the attention of the common folk. In other words, what I'm trying to say is that people read about Einstein's thing not because they were trying to read science, but because they were trying to read about the total solar eclipse. The second reason that comes to my mind is the use of the word relativity. If one tells a non-scientist that quantum theory is being put to test, it is hardly conceivable that the listener will feel excited, because the word quantum is not known outside the realm of science, and so the importance of the statement cannot be perceived until one explains what is meant by the quantum theory. But before the person starts to explain, the other person is gone, not interested. But if one says that we are testing the theory of relativity, the effect is different, because the listener can imagine a meaning and feel curious about it. The meaning might not be the correct meaning, and problems also arise because of the imagined wrong meanings, as I will discuss later. But there is no doubt that the curiosity is tickled. And this is not just a coincidence that the curiosity is tickled. Einstein had a knack for this thing. He is the only major scientist that I can think of who wrote elaborate books for the common person explaining his theories. This book, Relativity, the Special and General Theory, came out in 1916, just the year after his general theory came out. No major scientist at the height, at the peak of his career, spends time writing books that will be understandable for common persons. So he really wanted to communicate to people. And that's a big difference. Maybe the difference is best understood if I just give you the story of another great scientist of his time, Paul Dirac. If you ask me to name two greatest scientists of the 20th century, I will name Einstein and Dirac. And Dirac's name is not known outside physics. Engineers know him because they say he is the inventor of the delta function. Okay? But Dirac's theory is not known outside physics. Why did this happen? Well, you want to know how Dirac reacted to such things? Some journalist asked him in an interview, can you please explain your theory in simple terms so that it can be understandable to general public? Dirac was a man of few words. So he said, no. Einstein would have tried. Einstein used the word relativity at the very beginning of the very first article that he wrote about the subject in 1905. He, of course, wrote in the German language, where he used the word Relativität. His article was first translated into English by Meghnad Saha, who used the obvious English equivalent, relativity. And I am not even saying that Meghnad Saha used it in English for the first time. Maybe already it was used in scientific literature before him. And such obvious translations spread into other European languages as well. Relativité in French, relatività in Italian, relatividad in Spanish, and so on. Now, the word relativity did not appear in the title of the paper. The paper was titled On the Electrodynamics of Moving Bodies. Of course, an English translation. Einstein started his arguments with two axioms. The first one is, and I quote, if one observer moves with a uniform velocity with respect to another observer, all laws of physics will appear to be the same from the viewpoints of the two. One observer is moving at a uniform velocity with respect to another. They will see the laws of physics to be the same. This realization was not new. More than 250 years before Einstein, this proclamation was made by Galileo. When Einstein wrote this down, he added a comment before it. It can be called the principle of relativity. The name is strange. The word did not seem to exist before that. I don't think Galileo ever used an equivalent word. At least I never found it. I never found anything in the translations of his work that I have read. And I have read a lot of Galileo. When Einstein explains the principle, he did not have to use the word relativity either. I just stated the principle to you. I have never used the word relativity. One observer moving at a uniform velocity, etc., etc. So, he used the phrase with respect to, which means that he was talking about the relative velocity of the two observers. But the message that is more striking and more important in the fact is that the laws of physics do not depend on this relative velocity. Do not depend on this relative velocity. They are absolute and not relative. This invariability is the essence of the axiom and should have been emphasized if a name were to be coined for it. And yet Einstein called it the principle of relativity. Why? That's hard to guess. But the theory came to be known as the theory of relativity, which we all know. However, even if he could have avoided the word relativity for stating his first axiom, he would have needed it soon after. After his first axiom, he presented his second axiom, which goes like this. If one observer moves with a uniform velocity with respect to another, they will measure the same speed of light through vacuum. Again, the word relativity doesn't appear. It is rather the same speed of light, the invariance. So suppose one person is sitting quietly on the platform in a train station and another person is in a train passing that station at a speed of, let's say, 100 kilometers per hour. The two will have different answers for the speed of a car moving on a road next to the train tracks, but if they measured the speed of light, their answers would be the same. It might sound bizarre if there are people in the audience who have never taken a course on relativity, so let me explain a little bit. Einstein pointed out that the measurement of speed involves the measurement of time, of course, because the speed is nothing but the distance covered in unit time. Therefore, one should carefully think about how time is measured. Einstein did the careful thinking and reached the conclusion that if two events occur, two observers will not necessarily agree on the time elapsed between the two. The measurement of time will depend on the speed of the observers. That part of the paper where this argument was described was understandably subtitled "The Relativity of Time." This is the first time that the word relativity appears in his paper. And the word spread outside the field of physics research. And a lot of misinterpretations started pouring in. Everyone suddenly came to believe that Einstein has proved that time is relative. What would that mean? Oh, if one stands in a long line for booking a railway ticket, even after 10 minutes it would feel like 1 hour has passed. Whereas, if one talks to a close friend, even an hour would seem to flit in an instant. This is relativity of time. As if this was not known earlier. As if Einstein was performing research on the psychological perception of time. Whether it is a boring wait in a queue or a pleasant conversation with a friend, one can easily find out how much time has elapsed if he or she just looks at a watch. In the midst of such juicy and fanciful jugglery, the fact that was lost was that Einstein was really talking about how the watch behaves, and in particular, that its behavior depends noticeably if it moves at a speed close to that of light. I have used the word misinterpretation earlier, but in reality, what happened was actually much worse. If someone really wants to give an interpretation of some theory and makes an honest mistake, that can be called a misinterpretation. What happened with Einstein's theory was nothing like that. People who forwarded these interpretations did not seem to have any interest in understanding what Einstein's theory was about. They heard some words floating in the air, added their own coat of imagination, and created a fiction out of the hodgepodge. Einstein's theories spread in the same way that gossip spread or stories of scandals spread. The regrettable aspect of the whole thing lies in the fact that the two papers that Einstein wrote on relativity in 1905 were very easily readable. The first article was divided into two parts. In the first part, there were 5 sections in which he laid down the foundations of the theory. This part and the entire second article can be read without having any specialized knowledge beyond 8th grade school algebra. In the second part of the first article, Einstein relates his theory to Maxwell's theory of electromagnetism, and this part requires a little more preparation for the reader, but the main idea of relativity can be understood even if one skips this part. Einstein's conclusions were stunning. It was not easy to fully appreciate his conclusions for someone trained in the classical ideas of physics, but the way he reached his conclusions did not involve any sophisticated mathematics or very abstract reasoning. With sincere efforts, his arguments should have been understandable to anyone with a good school education. Advanced knowledge of physics or mathematics was not needed. But once one is attracted to gossips, the level of sincerity goes down. Rather than the arguments of Einstein, what grabbed the center stage were jocular tales made from some buzzwords which appeared in his papers. Einstein became unimaginably famous for all the wrong reasons. Gossips or scandal stories have this characteristic that once they start, they become more and more elaborate. Einstein's case was no exception. Very soon, people started saying that Einstein had said that everything is related. And in the list of everything, many things were included about which Einstein did not say a word or did not even think about saying anything. Let me give an example. Somewhere I read that when Einstein was asked to explain the main idea of his theory of relativity in very simple terms, Einstein told the following story. Two friends are walking and they have to go to some distant town. And it's a desert-like road. One of the friends is born blind. The other one who is accompanying him is helping him. Now, at some point, the blind friend became very thirsty. They came out with some water, but the water was already exhausted. So he told his other friend that I really cannot move without having some water. So the second friend said that, well, there is nothing really close by that can be seen, but maybe in some far distance there is a village that can be seen. So he told the blind friend that, okay, why don't you sit here and I will just run to the village and get some water for you. But when he reached the village, he could not find any water. The villagers told him that it's a drought time and they are themselves not getting any water. So what do they do to survive? Well, they actually eat a kind of some roots of a plant which is very juicy, and if you put it in your mouth, the juice comes out, so that sort of takes care of your thirst. So they gave one of fruit of that kind to this friend. And so the second friend comes to the first friend and said, okay, now, this is the thing, you put it in your mouth, and so that will quench your thirst. So the first friend said, what is this? So the second said, this is a kind of a white fruit. So the blind friend said, okay, I understood the fruit. What is white? So the second friend said, well, white is a color. It's like the color that cranes have on their wings. So the other friend said that, okay, I understood the wings, but what is crane? So he said that, well, crane is a kind of a bird which has a bent neck. So I said, yeah, I understand what is neck. What is bent? So then the other friend took his hand and said, look, I mean, this is straight and this is bent. So then the first friend said, oh, now I understood what is the color white. If this is an explanation of Einstein's theory, it's a very stupid one, because it had absolutely no connection with the theory of relativity. If this was meant to be humor, it's a very cruel humor. The way an average person perceives color is not accessible to a person who is born blind. In this sense, one could say that the perception of color is different to different persons. But to make a joke out of it is definitely irreverent. And surely, the theory of relativity says nothing about the relation between perception of color and some kind of physical disability. Rather, the main point of the theory is the relation between speed and time and some related things, as we have said before. It's impossible and ludicrous to believe that Einstein told this story to explain his theory. And if someone else had said it, either he or she understood nothing about the theory of relativity or suspended all standards of responsible behavior for the sake of being funny. I read a story in a book of Jewish humor A grandson is explaining the theory of relativity to his grandfather. And the grandson is not a physicist, so the explanation contains jokes like the one I just mentioned about the blind friend. Or supposedly profound statements like an hour spent with a good friend feels like a moment, this kind of thing. Upon hearing, Grandpa commented, "This Einstein fellow of yours gets paid for preaching such nonsense? What a shame." Shame indeed. It's not Einstein's shame. It's a shame for the whole of humankind that such irresponsible stories go by the name of serious discourse. Another kind of stories also come to mind, which probably should rank among the same kind of irresponsible stupidity, but usually go by the label of science fiction. I'm giving an example without naming any names. A teenage boy found that his parents fight a lot with each other, so he went back to a time when his parents were both teenagers, when they knew each other but were not yet involved in a serious relationship. He made some changes in the series of events that took place at that time in such a way that the relation between his parents became very sweet and would last like that forever. When he came back to his own time, he found that his parents had a very happy family with 3 children, including himself, of course. I have nothing to say if this story is taken as a tale of unbridled imagination. We like fairy tales or tales of miracles if they are presented well and if they are presented like stories. But the unfortunate part was that a level of science was attached to the particular story that I have in mind. Most stories of its kind have this level attached to them. The label asserts that there is nothing impossible in time travel because Einstein has already proved that time is relative. We only need to wait for the right technology for making time travel. So the whole story is served with a scientific packaging. The protagonist of the story approaches some scientist in order to make the time travel, and the scientist, after some effort, and of course the scientist looks like a madman, so after some effort, he manufactures a vehicle which would make the time travel possible. And some high sounding mumbo jumbo was uttered by the scientist as a spicing to the main dish, and those lectures mention the name of Einstein and his theory of relativity. This is the formula. Do you really think that Einstein was so stupid that he could not have detected that his theory was inconsistent if he had found that according to his theory it was possible for a daughter to be born before her mother? He talked about the relativity of time, no doubt about that. He showed that 2 events happening at 2 different places might seem simultaneous to one observer, but not so to another observer. He also showed that 2 observers might disagree on the order of 2 events. So something which is earlier with respect to one observer might be later with respect to another. But this last statement would not hold for any 2 events and any 2 observers. A disagreement might arise only if the 2 events are separated by such a distance and such a time that even light cannot travel that distance in that time. Needless to say that if a ray of light had started its journey at the time and place where the teenager's parent lived, it would have crossed the Earth, the entire solar system, our entire galaxy, and much more by the time the child was born. So no matter how relative time might be, no observer can have any doubt about whether a child was born before or after his or her parents. We can paraphrase the point in a little bit different way. If 2 events have a cause and effect relation between them, then there cannot be any confusion about their order. The cause must precede the effect. Einstein's theory of relativity indicates that no signal can travel faster than light. In order to have a cause and effect relation, there has to be some sort of signal transmitted from the cause to the effect. That signal cannot possibly travel faster than light. So all these stories of time travel no matter how attractive they are in their presentation, have no connection with science, no connection with Einstein. I have been talking about the first paper on relativity by Einstein. Among the 5 epoch-making papers that Einstein published in 1905, there were 2 which concerned the theory of relativity. Let us now talk about the second one. This is where he proposed the famous equation which comes just after the 2 which have been written. And this is a cartoon by Sidney Harris, whom I respect a lot. It means that if an object has mass m, it has some amount of energy just because of this mass. It can have energies from other accounts. It can have kinetic energy if it moves and so on and so forth. But there will be some energy just because of its mass. And this is the amount, or no, not that, the E equal to mc square gives you the amount of that energy, where c is the speed of light in vacuum, 300,000 kilometers per second. How famous is this equation? Let me recall a comment by Stephen Hawking to illustrate how famous this equation is. Actually, I could not find the book to quote it exactly, so I am quoting from my memory. Hawking essentially said that if one wants to write a popular level book on science, the publishers keep reminding the author that every equation the author puts into the book will cause a decrease of the number of readers by 10,000. There are only a few exceptions to this rule, and E equal to mc square is one of them. Hawking said that this one has a different kind of appeal. Readers feel cheated if this equation does not appear in the book, and delighted if it does. Now, the name of Hawking came. So I have to make a few comments about Hawking. Hawking shared something with Einstein. Hawking also became famous much later, and his fame also was like Einstein's fame. At least one thing they shared in common. That was the zeal for reaching the general public. Like Einstein wrote his book that I showed you, the Relativity, Special and General Theory, Hawking also authored many books. He was not always very understandable in the books. The first book, personally, I considered to be a disaster, but people were very much amused that he was making some overtures to them. And even if they did not read the first book, they at least bought the first book. So the name spread around. Let me come back to E equal to mc square. Extreme misunderstanding and mal-explanation instead of misinterpretation, I want to use the word mal-explanation, have become the fate of this formula. To illustrate, I will tell you about a personal experience. Once I was having just a lazy afternoon chat with some friends. One thing followed another, and at some point one of us made the remark that some movies, he was talking of some specific Hindi movie whose name I cannot remember, but he said that some movies sometimes show some ridiculously impossible things. As an example, he talked about a movie where it was shown that a band of thugs were trying to kill the heroine by electrocuting her. So they tied the heroine to an electric wire and sent a strong current through them, but the heroine never died, of course. Heroines don't die in stories. As the current was racing to the heroine, the hero actually came on a horseback and overtook the current and cut the current. So after relating this storyline, that person, a friend of mine, he said that this kind of stupid things are not shown anywhere else. Only Hindi movies show such trash. So then I said, why? I have seen English movies which people call science fiction movies, but which show that a person stands in a place which looks like a shower, and then suddenly there is a whoosh kind of sound and the person becomes energy. That is equally stupid and equally ridiculous. The guy who narrated the story earlier then said that it was not at all strange or stupid because Einstein had showed that matter could be transformed to energy. E equal to mc square. I was stunned. I tried to explain that Einstein never said any such thing. An object can have energy for many reasons. And Einstein said that one of these reasons is its mass. And the energy due to mass is calculated by multiplying the mass with c square. So if all the energy due to mass could be converted to energy of some other sort, that would be the amount obtainable. But Einstein never said that the whole mass can be converted to other kind of energy, because he knew quite well that matter has some other properties which cannot be destroyed. For example, there is electric charge, there is barrier number. These things cannot be destroyed, and energy does not have these properties. But my pursuit was useless. Our friend kept saying that I did not know what I was talking about. I also realized at some point that there was no point arguing with him because he was not alone. He was definitely accompanied with the people who made those kind of movies, and multitude of people who saw those movies or read stories of the same sort. They all shared the same belief. So here as well, Einstein's fame came through misinterpretation of his theory. There was another kind of fallout of Einstein's fame in the form of anecdotes regarding his personality. Parts of these anecdotes are based on truth. Einstein did not approve of various social norms, so he decided to defy them and go by his own rules. In his time, not wearing a necktie was considered almost a barbarian trait among for an European gentleman. Einstein never liked wearing ties. Look at this picture. Who is the odd man out? 1, 2, 3, 4, there are 7 people. There is only one person not wearing a tie. It was unthinkable at that time. So, in another article, I also projected Einstein as a fashion guru. And I think the lot of the reason that now in European and American universities you can go to a class wearing shorts started with Einstein actually. Einstein did not wear shorts, he could not go that far, but he started the trend. So anyway, he completely decided to do away with neckties at a mature age. It is also said that he used to use the same soap for shaving and for bathing. If asked, he used to say that he did not understand why 2 different soaps were necessary. He did not wear socks and used to say that his feet sweat if he wore socks, causing discomfort. It may not come as a big surprise to us who live in much warmer climate, but in colder climates this is considered strange behavior. So some stories regarding such traits were inevitable. But in the anecdotes, wild imagination overtook the truth. Word spread to the effect that Einstein was a very absent-minded person. And this is an adjective, of course, which many people love to use when talking about scientists or about academics in general. In one story, Einstein boarded a bus and paid for his journey, but when he got the change, he miscounted it and challenged the conductor, upon which the conductor shouted at him and said, "Didn't you learn to count in school?" Ha ha, what a funny story. Einstein must have been thinking about some profound theory at that time, which is why he miscounted the change. The absent-minded scientist. When the great Bengali writer Bibhutibhushan Bandyopadhyay wrote a story named Einstein and Indubala, those who haven't read it, there is a translation available on the internet, and this you can take as an advertisement because the translation was made by me. This is a good thing about translating. You can promote your own thing because actually it's somebody else's thing. Anyway, when Bibhutibhushan wrote a story named Einstein and Indubala, about the famous scientist and the famous actress coming to a small town on the same evening, the portrayal of Einstein's character followed exactly this prototype. It is not clear at all, at least to me, whether Einstein was an absent-minded person. If some professor did not wear a tie in the first half of 20th century in Europe, that could not have been because of absent-mindedness. See, an absent-minded man might wear a shirt inside out, but an absent-minded man doesn't forget to wear the pants while going out on the streets. There are limits to absent-mindedness. And not wearing a tie was comparable to not wearing a pant in early 20th century Europe. So it is impossible to assume that Einstein forgot to wear his tie every day. Rather, something should be true to the contrary. I mean, it required a conscious effort and a lot of courage of conviction to go against the social norm, which Einstein did. About the incident of bus, I'm not saying that it never happened. It might have happened. But whether or not it is true, it does not provide a big key for understanding Einstein. Any person can make a mistake once or twice in counting money. Even Einstein can. One can make a mistake while having some deep thoughts. One can also make a mistake while thinking of mundane household issues. There is no reason to assume that if Einstein had made the mistake, he must have done it for the first reason. And the whole incident might not even be related to absent-mindedness at all. I would guess that the incident, if at all true, happened soon after Einstein came to America. The coins of the new country were unfamiliar to him, which caused the mistake. It happens to almost anyone who travels around the world and has to use many different currencies. But once it happens to Einstein, people cannot think of a different explanation. People just build an aura with that. I'll tell you of a similar aura about somebody who is very close to me. It's Ashok Sen, my friend, my classmate. There is an aura about Ashok, and a lot of people know Ashok's name. Once somebody who was introduced to me somewhere, and so he said, when he heard that I was a student in Presidency College, and he said, were you a contemporary of Ashok? I said, yeah, Ashok was my classmate and he was one of my closest friends. And he said, oh, this guy is really incredible. I said, what incredible thing you know about him? So he said, once he mentioned somewhere that I was going with him, and he was just wearing a pair of rubber sandals, and while we were walking, the strap of one of the rubber sandals broke. And do you know what he did? He just asked for a safety pin from somebody and just put the safety pin on the rubber sandal and continued walking. Can you imagine? What a great person. I said, let me ask, what would you have done in that same situation? And he said, well, I would have asked for a safety pin also. I said, so you should understand that Ashok is great, but not for that reason. Try to find the real reason. Now, there are some more extreme stories or anecdotes about Einstein, which have absolutely no connection with the truth. Let me see, how much time do I have? Depending on that, I will skip this story. 2-3 minutes? Okay, maybe I'll tell the story. Okay, Einstein, of course, would get invitations for lecturing at different places. Now, if it's not too far, then he would go in a car. I think he did not know how to drive, but there was a chauffeur who was given to him, and the chauffeur would go with him. And during the lecture, what would the chauffeur do? So the chauffeur would just come and sit in the rear of the audience and would listen to the lecture. Now, it went on like this, and the chauffeur had heard the lecture many times. And then once, when there was an invitation for a talk, he proposed to Einstein that he wants to give the lecture himself. So Einstein said, okay, I have no objection. So they changed roles. The chauffeur gave the lectures and the real Einstein sat in the back and listened to it. Now, after the lecture, there is a question and answer time. So some person asked a question. Now, some of the questions were also something that chauffeur heard before, so he could also give the answer to the question. But then there was a new question. So then he said, oh, this is such an easy question that even my chauffeur can answer this. And he pointed out. Okay, it's a very enjoyable story, but far from true. In order to believe this story, I have to believe that the people who organized the lecture did not know how Einstein looked like. That's ridiculous. And to think that Einstein allowed his chauffeur to speak of him in an invited lecture, it's calling it incredible would be an understatement. It's malicious and disgraceful. It is not clear whether the fame brought about the unfortunate exaggerations or whether the exaggerations helped propagate the fame. Which is the cause and which is the effect? It is not clear whether Einstein wanted fame at this level. From the account of his biographers, it seems that he did not. He was bothered by the fame and often irritated. In 1930, in a felicitation ceremony held at Hollywood, and you know that there is probably no educational institution in Hollywood. In reply to the praises showered on him, he said, I am really thankful to you for saying all those nice things about me. If I had to believe everything that was said, I would have to be insane. But since I know that I am not insane, I could not believe all that was said about me. At the beginning of that trip, when he boarded a ship from Antwerp in Belgium, he said to the journalist who gathered there for the occasion, if you want one comment from me, that would be it. I want to be left alone. Too much curiosity about people's private lives is something that I find indecent. If the newspapers stop meddling into such inconsequential matters and turn their attention to issues which are really important, it would be much better for mankind. When he was informed that some special radio connections have been devised so that he could talk to his relatives or friends during his voyage on the ocean, he quipped, I hope the journalist will not call me while I am midway on the ocean to find out whether I slept well at night. When he reached England, he wrote in his diary, the journalists here are also very restrained. They have to be praised for that. The world has a lot to learn from them. This is how he felt about the over-inquisitiveness regarding his personal life. And what might he have thought about the way his scientific work appeared to the general public? Nobody is pleased with this distortion of his or her work or trivialization of one's discoveries because of oversimplification. It can be guessed that Einstein was not very happy with the fact that curiosity about the theory of relativity turned into futile madness. But there is another side to the coin. He probably could have found some solace in the fact that he was not alone in this misfortune. Among the others who could give him company, Newton's name comes immediately to mind. Newton wanted to explain motions of objects through his 3 laws of motion. The first 2 I'm not talking about because most people outside the field of physical sciences are not even aware of the first 2 laws. But then comes the 3rd law, which says that the force between 2 objects is felt mutually. In other words, it is not fair to say that one object is pushing or pulling the other one. Rather, it should be said that there is a mutual force of repulsion or attraction between the 2 objects. But Newton stated this law in a somewhat weird way. He said, to every action, there is an equal and opposite reaction. If object 1 pulls object 2, then object 2 is also pulling object 1 with the same force and so on. So mutual attraction and repulsion is the key of the idea. Newton wrote his laws of motion, and the news of the third law spread to all disciplines. There is no count how many times this law has been misused. One political party won an election and lost the next one a few years later. So everyone started talking about Newton, the inevitability of Newton's third law. One person cheated another, but then somehow landed up in distress himself, and thus Newton's laws were vindicated. Now, what happened to the person who was cheated in the first instance? What happens to many cheats who spend their life merrily? No one talks about Newtons while talking about them. So Einstein definitely heard discussions like this on Newton's law. So when people started talking nonsense about his own theory, probably he was not shocked. Probably he had to endure more punches than Newton. We do not hear about Newton's personal life very much, but in case of Einstein, almost nothing was spared. His personal life, his marriages, his intimate habits, and yet probably he found some joy or maybe even some pride in thinking that he was in the same league as Newton in this regard as well. Thank you.
Only nuclear disasters of this world, that is Hiroshima and Nagasaki, and the theory behind those disasters was given by Einstein. So the fact draws a lot of attention.
Okay. He said about his contributions to the Manhattan Project. He did not contribute to the Manhattan Project. He is probably the only one of the famous scientists who refused to join the Manhattan Project. Okay.
But still, the fact that his theory was behind that development of nuclear.
Whose theory? Einstein did not say a single word about nuclear reactions. Never. It was just promoted that Einstein's E equal to mc square is behind. Everybody knew about the law of conservation of energy before Einstein, right? Law of conservation of energy were known. So if you can, change some form of energy into some other, you will get the energy. This was known before Einstein. So what did Einstein do in this regard? Nothing. The letter is not his scientific work.
It's not, but Leo Szilard approached Einstein and he had written.
The letter is for stopping it.
He initiated it. He said that the bomb should be constructed less the Germans with Heisenberg.
Okay. You are talking about the first letter. I'm sorry. Yes, he wrote. Yes. But I have never heard that his fame contributed to that. This was in 1943.
Much later.
Einstein was already, famous and known to everybody in the world by that time. But no, I mean this is a completely strange propaganda that E equal to mc square contributed to the nuclear energy. It did not. I mean.
Sometimes I get surprised by the fact that he was very much famous for his works on relativity, whereas his works on Brownian motion and photoelectric effect, which actually photoelectric effect gave him the Nobel Prize, was not that popular. Was that because Brownian motion was also something strange to common people, right? And you can actually see that every time using, but that was not the
No, you cannot see. You have to see it with microscope.
Exactly.
Yeah.
But this was somehow also a strange thing, but still relatively won in the computation, right?
Yes, and that is what I was saying. At some point I said that the one reason is the connection with the solar eclipse. And the second thing is that the use of the word which easily the philosophers could steal. Brownian motion, they cannot do anything like that. But you are right, I mean they are known, and in fact I would add one more. There is a very beautiful statement by Leonard Susskind, who said that in 1905, Einstein started 2 revolutions and ended one. The one he ended is also equally good. That's the existence of molecules. Before Einstein, the existence of molecules was not true. This is the Brownian motion. That's the thing. Okay, so.
There's another there.
Hello. So this is just a silly piece of trivia to add to your story.
Yeah, please.
The Hollywood story that you narrated, incidentally, there was a dog which actually traveled in time in that, and interestingly, the name of the dog is Einstein.
Oh.
In Back to the Future, I think you're narrating Back to the Future.
Yes.
So the dog of the scientist is actually Einstein.
That's right. Yes, I forgot that. Yeah.
The last one.
So I just wanted to ask you about this order of infallibility that is associated with some scientists like Einstein or something. So you just shed a bit of light. The Einstein-Bohr debates.
Einstein what?
Bohr debates, where he was questioning that the quantum mechanics is a fundamental theory of nature or not. But later on, much of Einsteinian views were probably discredited to a substantial extent, and Bohr was vindicated. So how has that impacted?
To his pen, nothing. Nobody outside physics knows about Einstein-Bohr debate. Yeah. But if you want to make me comment about the debate, Einstein was skeptic about the way quantum theory was developed, but also his criticisms were beautiful criticism, and the quantum theory developed a lot because of his criticisms. The EPR paradox is now used for this quantum cryptography and all these things, not the cryptography but teleportation, this kind of thing. EPR paradox is used a lot in a lot of these things. Okay, so his criticisms are also scientific criticisms. It's not just malicious.
No, they are not that.
Yeah. So it's good. I mean, it's good that he was criticizing the thing. The theory actually helped. It helped the theory to grow.
But the Bell's experiments, Bell's conjecture, and the later experiments by Alain Aspect, did they suggest that this instantaneous?
Yes. Quantum mechanics was vindicated. There is no question about that. But the point is that the other viewpoint had to be shut down scientifically, not from a just a philosophical point of view. And that's what Aspect did, and that's the way science progresses. Fine. I mean, Einstein doesn't have to be on the right side and everything, but what he did is the right thing. He proposed an alternative, and not only him. I mean, there was some alternative which was tested. But his fame doesn't depend on anything regarding this. You ask anybody on the street, you ask anybody in IIT Kanpur, I mean, outside the physics department, Alain Aspect.
I request ma'am to give it to the